Yeah, as y'all can see, man, it's been a long time I done been doing iron stream. So today we finna be doing iron stream. So yeah, first up, I'm finna be doing my homework. Yeah, alright, let's get it. So finna be doing the homework. Yeah, so make sure y'all so. It's been so long I didn't been doing iron stream. So yeah, we back at it again. Yeah, so let's go. Yeah, hold on, y'all. Hold on, let me find my password first. Alright, so yeah, we'll log in. Find out do some homework. What's going on? Hello? 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 Alright, yeah. Hold on, y'all. Alright. We back. So we're finna be doing some homework with her. You feel me? Yeah, nothing too crazy. So let's get to it, you feel me? Alright. Alright. Let's see what I'm missing, so. Damn, it's spring break package. Great, right? Yo. Damn. Spring break package. I'm finna do it first. Then I'm finna be writing a whole thing, bunch of stuff. So it would take me like 2 or 3 hours. Let me see what I'm missing over here. I think that's only 3. I only got 3 stuff to do. Yeah. Yeah, like I said, I'm finna be doing them, so yeah. Damn. Let me see if I can do this. Let me use the calculator on this. So. Alright. X equal -1 over 2i. Good. This only in this section. Much. Damn. Yo. Oh, only one. Oh, I'm tweaking. That was a. Oh, that's what I was about to say. I was about to say, like, what? How I'm gonna be doing all? Oh. I thought that was like a whole, like, you feel me? So we good, y'all. Yeah, I'm finna use calculator on that phone. So yeah, that's my old phone, but I've been having this phone for like 3 years. Yeah, 3 years. So. Yeah, I'm solving them. I was about to say, like, how many questions though? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 45. Damn. I gotta do 45 questions, y'all. Just give me next question, please. Damn. Why my phone is tweaking? Words. I got shit like this, bro. I got shit subscribe, alright? Yeah, X. -505. How you doing? Yeah, I got it. Finally, yo. Finna put the answer right now. -1. Alright. Oh my god, the whole solution is crazy, right? Look at this, yo. The whole solution I have. Look. To this on the cell phone. I might just read it and try not to do it on my head. You feel me? So yeah. Damn. I hope they don't give more like this. Please, I don't like dealing with stuff like that. So yeah. I hope they don't give that much. Alright. What's the answer? No, X. Is it X? Yeah, X. 2.9. You left something. Oh. What? How you do this? 2.9. What is inequality? I have to put inequality too, so. How you do it? Snap. Alright, I'm gonna copy this. Plus 5x alright, 50, right? 50. Yeah, I got it right. Damn. Let's take my love to man. I got it right. So yeah. Oh my god, they give another one. Oh Lord. After this one too, I'm much. They got golf in there too. They got golf in there. Yo, I don't feel like sitting down and work. I feel like that. So. Alright, 15. Damn, I'm finna sit over here, please. Yeah, this should be good. $15 plus 25x. Y5 x equal 4. Yeah, x equal 4. Boom, I got it right. I need a pillow behind me, so yeah, it's like kind of hard. So I need a pillow behind me. Oh yeah. Now I feel good. I feel good. Alright, so yeah, put the pillow behind you. And let's get to it. Let's see. 5 hours. 5. Yo, what? Let's say 5. I don't know. How is it 3 hours? Boy, they just told me that shit 3 hours. Alright, wait though. See? I bet. Nah, they be tweaking. Yo, what? Yo, what, bro? M equal. Over 5? No, over 3. I'm getting. Please. Please do not write any equal sign. Is it X? Please do not write an equal sign. What? Please do not write an equal sign in your answer, for example, if you are. Yeah, that's right. I know how to do this. Rising one. Yo, I forgot how to do it. Yo, I forgot how to do Rising one. Oh my god. Things like that. I don't know. But come on, man. How was it like the best? Like the best? Like that was the best topic I know of. Oh my god. Damn, I'm hungry, bro. I'm 4 and 6. 4 and 6. Or 2 line. How you do that 2 line? Yo. Is it negative or I'm tweaking? Yo, what? Like that? I'm gonna move on, but come on, I cannot. Can I be stuck in one question?
Lagi biar sukul. Pero kung mga pwede,
Yun.
yung sal?
Damn. My neck is hurting. I forgot to put y equal. Y equal. I'm trying to be solving this problem. X equal negative. Ah, dude. This problem is so hard. Man, I'm trying to solve it right now. Fully. More. What? Multiply. How you do time? I don't know if you said no, I'm tweaking. My neck is hurting. Oh my god. So yeah. Damn. Oh. Jeez. No. much. Final one elimination. An elimination, but oh my god, man. Much question, like 45 questions. Like, final elimination one also. Yeah. Oh, I got that pillow for the view. -2. -6. I feel like elimination is easy, so yeah, don't give me graph right now. I'm like, I don't know anything about graph anymore. Yo, I used to be top behind graph. I don't know, -1. Yeah, just give me like simple problem. I can do it. Yeah, I usually be the top, like the best. And graph, like you can give me any graph, so now I have to like master it again. I have to like when you don't practice that much, so yeah, you fall the trap. You feel me? So you gotta practice every day. So yeah, that's what happened to me, man. Yeah, like I usually be the best. I usually help people a lot. So, like help like a lot. So that's what happens when you don't practice. You gotta practice every day. So yeah, you practice make you better. You feel me? So yeah, 27. So like yeah. And then, oh my god, Doja Boy, please, come on. I'm gonna skip it, come back later. Oh my god. I'm gonna come back later on you, so don't worry. I'm gonna skip them, yeah. How to do the Q2 over? I plus Yo, what? I think I should be doing the head puzzle first. Oh, GH should be first. G. Yeah, G. That's why you need to prepare. Let me see if I put 16 is it gonna work. Oh, I did something wrong. That's why. I should have put 16 there. That's all. I said, let me try it. You got to dang, yo. You feel me? I got them beer too, like. Yeah, easy. Oh my god. Oh my god. I didn't say explain it. I gotta wait. I should have done the head puzzle, man, not this. Just take my long. Damn, no, boy. Alright, boy. Polynomial. Seven. The whole video. Now they give me the whole video. Look at this.
So the pattern of a polynomial could be one or more terms, where each term essentially will be of the form a x to the n, where n is a positive whole number. So for example, 7x to the third would be considered a polynomial because the power of the variable x is a positive whole number. But we could have multiple terms. So a binomial would be two terms, each of which follows the pattern. So 2x squared would be a polynomial. So this here would be a binomial in that there are two terms and each of the terms is considered a polynomial. Now, what if we had a term such as 6x? Well, that actually does have an invisible power of 1. And since 1 is a positive whole number, that works. And if we added on a constant like 7, this would still be considered a polynomial because technically we could think of there as being x to the 0. And since x to the 0 is just 1, then we just get 7. So even though 0 is not positive, if the power of x is 0, that is still okay for polynomial. So we may have any powers of x, like 3 or 2, and we may have constants, and that's fine. Now, the degree of a polynomial is the highest power. So in this case here, 7x cubed plus 2x squared, the degree would be 3, because the highest power of x is 3. So this can get a little more complicated because some terms might have a 6x squared y to the third. Now, a polynomial is allowed to have more than one variable in it, but each of those variables must have a power that is not negative and not a fraction or decimal. So considering these are both positive whole numbers, this is considered a polynomial. But if we add those, that would be 5. And the degree is actually going to be the sum of the two exponents if there are more than one exponent, okay? Now, some things that would not be considered a polynomial would be something, for example, with a radical, like 2 square root of x. Now, you may or may not know, but the square root of x could be thought of as x to the 1/2 power. Since that's not a whole number, we would say that anything with a square root inside is not going to be considered a polynomial. However, if the coefficient has a square root and the x is not inside the square root, then the x's power is 1, and this would still be considered, yes, a polynomial, even though the coefficient is irrational. The other thing that you might see is something like 3 over x squared. Is 3 over x squared considered a polynomial? Well, you may know that 3 over x squared can be rewritten as 3 times x to the negative 2. So because that exponent is negative, we would say definitely not a polynomial. So polynomials should not have any variables in the denominator, and polynomials should not have any variables inside square roots. So considering that, let's do a few examples. In this case, for y, is that a polynomial? Well, y is a variable and its hidden exponent is 1. So we would say that it definitely represents a polynomial. Now, the number of terms is 1, right? 4y is one term. So just so you know, terms are separated by pluses and minuses. So 4y plus x squared would be considered 2 terms, okay? But 4y plus 7x squared y z to the third, it's still 2 terms because that's still 1 term because it's a bunch of factors being multiplied together. So in counting terms, we're really counting the number of things which are separated by either addition or subtraction. And since 4 times y is connected through multiplication, this is a single term and its degree is the power of y, which is 1. In our next example, we have 3 terms. This is the first term. then the subtraction means this is the second term, y over x, and the third term is 4x squared y squared. Now, because we have an x in the denominator, we knew that that could be written as x to the negative 1 power. This is not considered a polynomial, and that's all we have to say. In this case, we have 3 terms, and we have 3 different variables, which is fine. And this x has a power of 1, which is a positive whole number, so that's fine. This has a power of 2, and this has a power of 5. This is a polynomial because all of the exponents are whole numbers and positive. And it is a trinomial because trinomial is 1, 2, 3 terms. And the degree would be that with the highest power. So the highest power in this case is 5. So the degree of this polynomial is degree 5. In this example, we just have 2 terms. Now, even though the 4 is the denominator, we could actually rewrite this as b to the 4th minus 1/4 times b to the 5th. So this 1/4 is simply the coefficient, and the coefficient is just a real number, and that doesn't affect whether or not it's a polynomial. What matters is the powers of the variables. So because the powers are both positive whole numbers, we do say that this represents a polynomial. And the polynomial is 2 terms, which we consider a binomial, 1, 2 terms. And the degree would be the highest power that I see, and the highest power that I see is 5. So that is the degree. Next, we see 2 terms, even though each term is pretty complicated. This is 1 term, and then we subtract this second term here. Now let's look at all the powers. So the power of b is 1, and the power of c is 2. Those are positive whole numbers. Here, the power of b is 5. That's a positive whole number. And even though 6 is in a square root, that does not violate the rules of whether it's a polynomial. So it is a polynomial, and the polynomial is 2 terms, a binomial, separated by a subtraction sign. And the degree of this term would be 1 plus 2, which is 3. But the degree of this term is 5, and we say that the degree of a polynomial is the largest of the terms. So the degree is 5. In this example, I see 1, 2, 3 terms. Now, c divided by 8 is considered a polynomial because c's power is positive 1, and the coefficient is really negative 1/8. Now, we have 3 terms, so this represents a polynomial. I don't see any negative exponents or fractional exponents. And it's 3 terms, each separated by subtraction. Now, which term has the highest degree, right? So this one is c to the 1. This one is a to the 5th. And while 5 might seem bigger than 3, the degree of this term is the sum of the exponents. So the degree of this term is 6. So we say that the degree of the polynomial is equal to the degree of the term that has the highest degree. So that would be 6 in this case.
Don't touch the window. Just leave it like this.
Finally, we see an example where though this r is raised to the 1 power, this r is inside of a square root.
Just
so really,
stay on your iPad,
8
okay?
rad
Close the door.
r is the same as 8r to the 1/2 power. That is not a whole number. So if you have a variable inside of a radical, then we know that that is not a polynomial.
Taking a break. Alright. Let's get ready to work. Yeah. I don't know if I'm getting this. Yes. Alright, my sister calling me. We'll go right back in this. Listen, I have to go downstairs and eat and come back. So me gotta take a break. Yeah, hard work. Yeah, when you're doing enough. Yo, it's very good outside. What? I'm gonna go downstairs. I have to get my stuff.
Oui, il m'a
Yeah,
fait
y'all, I'm
puis pour
doing
30
some.
000 dollars. Si je me 30 000 dollars et puis je me fais avec, d'acheter
Finna,
ma moulin, acheter
finna
le mille.
finish.
Ensemble, ça fait commerce.
Yeah, so I'm finna be. Can I get some popcorn, please? Can I take the rest? You eat a lot. You eat the whole packet. Boy, you eat the whole packet yesterday, so let me get the rest. So yeah. Yeah, yo, I got some popcorn while I'm doing some like the homework so I can like chill and thinking. So yeah. I just wanna eat that burger. But like usually I don't eat burger in the morning. I eat like some good breakfast. Yeah, but they have pancake. I didn't want pancake today. I just wanna try something new in the morning. So yeah. But I'm already full. I don't know what's wrong, but I'm already full. So yeah, if I got some popcorn with me while I'm doing the homework with you. Oh, this can make me do the homework more faster. Pause. Yeah. So let's go. I don't know. It just. I don't know where I'm the. I'm not for the women. What? Am I tweaking? Yeah. That's too much. Alright. CV. X plus 4. Oh, yo, so guys, you mean I calculated this and this is equal X plus 4. I calculated. Damn. I got X plus 4, damn. Now they give me 5 questions to do this cooker, right? And I already got 45 to do, so why all of that? But not 45, like, you feel me? I did like most of it, so. Alright, negative focus, second power. How you do second power? Yo! No, please don't give me a question, second power. What? Alright. Two. But come on. Let me just take a screenshot real quick. Yeah. Took me a lot. No. Where did I get that 82 from? Yes. Come on. Let me do it again. Oh my god. Skip. Yeah, I'm skipping every question. I don't know what to do. So yeah. Then we're gonna come back later on. You gonna film me? That's what I do. That's why I do it. It was. No, but I don't wanna pay. Oh my god. Oh my god. Your balls. Oh my god. Just give me that. Oh, they were a calculator. Yo, I'm tweaking. I have a calculator. That's why I didn't use the calculator. I was not looking. -8. I see like how I'm gonna do the second power. Oh, 3x. This is easy, right? Yo, come on, let's go back. -2. -2x plus 8. Is it this one? No, that's the second one. So if I hit it over here, yeah. Oh, I got it now. Easy. No, let's go back. 3 x over 2 plus 3x. Yo, minus. Yo, what is this stuff? So, yeah. What time is it? I will get that done early, so yeah, I'm starting early, so you feel me? I just wake up in the morning, brush my teeth, everything. I started early, so like, feel me? The afternoon, I know I'm done with all homework. I don't have to deal with homework anymore. That's why I started early. To x over 2 what? Minus 6s. Minus 36. US over 2 minus 7x minus 49. So yeah. It's like I'm in school, like at home. I'm in school at home, you feel me? Yeah, I hope I finish like before 12 o'clock. I don't want to spend the whole day doing homework. Minus 2. I'm gonna put that phone in charge. Oh, yeah. Stop it. Well, let's stop it here. Anyway, boom. Go back. Yeah, so you mean I do 5 questions? Hold on, let me check the group chat real quick before I start doing it. X. Minus 3. You got too much. Hold on, let me check this. I'll be right back. I'm going to do something. Wait, hold on. All right, go on. All right, y'all, I'm back. So, yeah, I was doing something, so. Popcorn got dropped. Yo, I should not bring no popcorn in my bed, so. Yeah, I mean, yeah, I should do that, I guess. Let's get back to work. Negative. Negative 2x. Negative y. Over to plus 4x. Plus 4x. Yo, I got a whole acid to y. Oh my god, I got this one. What? I get 2x. To y, man. Keep forgetting, bro. Over 5. Plus 6x. 6x? 6x. Pause. Yo, what? What is I missing? Hold on, I'll be right back. Oh, yo, I'm back. Yeah, I'm back. Hold on, let me do something. Oh my god, my back is hurting. So we back. Okay, they go. Alright, 31. 51. Yo, how? Mm-mm. I've been doing that my homework since morning. I guess after 2 hours, I'm done. Yo, what? Well, I don't know. I'm tired, bro. Yeah, I got it right. Finally, but. Three x parentheses minus 1 minus 1 parentheses 3x plus 1 plus 1. Boom. Cherchez-le, posez-moi. Je vais t'en dire. Ou bon médicament déjà non. Pour bon Tylenol, on boit un médicament et puis boum, ou effet. On va jouer. I don't be showing the question I'm doing, so this is the question I'm doing, y'all. Yeah. No, but they should, not this one, they should give that on paper, but it's too much. At this point, bro, I'm halfway through. I have to lock in. I think I'm gonna do the pocket tomorrow. Because this is too much for one day. Now I have to watch the whole video. How many person I am?
Factoring quartic trinomial level 2. Factor the expression completely. So before we begin factoring, I highly recommend putting the terms in order from highest exponent of x to lowest exponent of x. So x to the 5th is first, but this negative 13x cubed should go next. And then the plus 36x goes last. So before I start factoring anything, I should factor out the greatest common factor. So I see that x is a term that goes into all of the terms here. The lowest power of x is x to the 1, so we can factor out an x to the 1. So we're going to take away an x from each term, which leaves us with x to the 4th minus 13x squared plus 36. So what's remaining inside is a quartic trinomial. Quartic means power 4. So a quartic trinomial can be factored just like a normal trinomial is factored, but one slight difference. So instead of x to the 4th minus 13x squared plus 36, what if we had x squared minus 13x plus 36? In this case, you probably know that we're looking for two numbers which multiply to positive 36 and add up to negative 13. In this case, we would get negative 9 and negative 4. And we know that this binomial times this binomial, if we distribute it out, would exactly equal this one. So we're looking for something very similar, except it needs to multiply out to x to the 4th. So the only way that would happen is if both terms in front were x squared and x squared. So x squared times x squared is x to the 4th. Now we still need the two numbers that multiply to positive 36. And you're going to see they also need to add up to negative 13. So we're still going to get minus 9 and minus 4, just like we got down here. And if you wanted to check by distributing, you would see minus 9 times minus 4 is positive 36. But the inside terms is negative 9x squared. The outside terms is negative 4x squared. Those would add up to negative 13x squared, which means that this is actually working. But another big difference between the quadratic, or x squared, and the quartic, or x to the 4th, is once I factor this, I might actually have to factor each of these binomials further. Because if I have an x squared minus a perfect square, 9 is a perfect square, we're able to factor that with the method of the difference of perfect squares. So x squared minus 9 is the same thing as x plus 3, x minus 3, because 9 is a perfect square and its square root is 3. But also 4 is a perfect square, so we do that again, x plus 2, x minus 2. So we actually have these 5 factors we can factor fully. Now these couldn't factor further because x is not x squared. Here with x squared, we could factor it to x and x. But if x is to the 1 power, this will not factor further while this one does. So we're actually going to have to type in all those things. X plus 3, x minus 3, x plus 2, x minus 2 in order to get full credit. In our second example, we see our x to the 5th term is last, so we're going to want to put it first. But that negative sign in front of x to the 5th is going to follow that term. If we rearrange terms, make sure the signs of those terms stay the same. So negative 2x cubed goes next because it has the next highest power of x. And this term has a positive in front, so we get a positive 3x next. Now, I see every term has an x, but I'm also going to want to factor out a greatest common factor of a negative, or a negative 1. The reason is I don't want my x to the 4th term inside of here to be negative. So if I factor out negative 1, I'm allowed to divide this by negative 1 and get positive x to the 4th, which is nice. But if we do factor out a negative, we must factor out a negative from all of the terms. So the negative 2 changes to a positive 2. The x to the 3rd changes to an x squared because I've taken an x out. And the plus 3 changes actually to minus 3, and the x is factored out. Now we can check here, negative x times negative 3 is positive 3x. So it is appropriate to change the sign. Whenever you factor out a negative, all of the signs will change on the inside of that trinomial there. So inside we do get that quartic trinomial. So we're going to carry down the GCF. And when we factor the quartic trinomial, we begin our binomials with x squared times x squared, which would equal x to the 4th. Now I need to think of two numbers which multiply to negative 3 and add up to positive 2. So we know 3 is going to be 3 and 1. But in order for these numbers to add up to positive 2, it would have to be a positive 3 and a negative 1. 3 minus 1 is 2, but 3 times negative 1 is negative 3. Now in the previous problem, both of these binomials factored further, but this one does not factor further for two reasons. Number one, it's a plus sign, and difference of perfect squares requires a minus. Number two, 3 itself is not a perfect square. The square root of 3 is not a whole number. So we cannot touch this. This is going to stay. So we are going to carry down negative x. We're going to carry down x squared plus 3. But the x squared minus 1, 1 is a perfect square. So we are actually going to take the square root of 1, which is 1, and minus 1. We do the square root of both terms, and one binomial has a plus and one has a minus. So this would be the final answer for this problem.
Oh my god. I'm back. I was watching the video. Oh my god. Okay, I'm almost done. Not almost, yeah, almost.
Mwen mwen medikaman mwen ka kompose. Ave. Oh, ok.
Hmm?
Medikaman mwen ka kompose.
Pou sa men ba la meti?
Mwen pa ale, non?
Non, pa meton ba sak joumen. Sak joumen ba la. Yo. A whole video again. How many video? Oh my god, vocabulary. I don't know.
Polynomial vocabulary. So before we start, I'd just like to define the concept of standard form of a polynomial. So for a quadratic expression, the standard form is ax squared plus bx plus c. For a cubic means that the highest power of x is third power. So the standard form would be ax cubed plus bx squared plus cx plus d. So what you notice is that in all of the standard forms, the powers of x start high. So for cubic, the first term is x cubed, and then each term thereafter is the power of x one less. So the cubic term is first, then the squared term is second, then the term with just the power of 1 of x is next, And then the final term is called the constant because there is no value of x next to it. It's just a number. So an example of a quadratic in standard form would be 3x squared plus 7x plus 5. Okay? So we see ax squared plus bx plus c. 3 is the a, 7 is the b, 5 is the c. Now, of course, this exact same thing can be written out of order, right? And this is no longer considered in standard form because the highest power is not first, okay? So what I'm going to define for you is the leading term. The leading term is what would be the first term if the polynomial were in standard form. So even though the polynomial is written out of order, 3x squared is still considered the leading term. And if I say leading coefficient, I just mean the coefficient, in this case 3, of that leading term. When we say constant, we're referring to the number that has no power, that has no x. So continuing here, we see negative 6 plus x cubed. So in this example, we could rewrite it in standard form as x cubed, or 1 times x cubed. Now you might notice that the cubic's supposed to have a bx squared plus cx. In this one here, there is no x squared term or term with x. So technically what's happening is it's 0x squared plus 0x minus 6. So this is equivalent to negative 6 plus x cubed. But if we wrote it in standard form, we would see there's zeros next to the x squared and x term. In any case, it is still a cubic because the highest power of x is 3. Now the number of terms is 2 terms because it's the number of non-zero terms. The constant term is the term that does not have x, which is the number negative 6. And the leading term is x cubed. So the leading term will always be the term that has the highest power of x. Now the leading coefficient is the coefficient of that. Now in this case, x cubed doesn't seem to have a coefficient, but you know that when there is no coefficient showing, that there is an invisible 1 as the coefficient. So we say that the leading coefficient is 1. In this example, we still see 2 terms, and we don't actually have to write them in order, but we could put the negative x first and the negative 6 second. Therefore, it's pretty clear that the negative 6 is actually, the negative x is the leading term. So since there's no squared, it's not quadratic, it's not cubed, there's no cubic, we say linear. Linear is when the highest power of x is just 1, or just plain old x. So this would represent a line if you were to do a graph. It is still considered a polynomial. There are 2 terms. In other words, it is a binomial. The constant term here is negative 6. The leading term is negative x. And once again, we shouldn't just write negative. The leading coefficient is always a number. In this case, there's an invisible 1 right there. So it's negative 1x. So we write negative 1 as the leading coefficient. Here we have several terms. So what is the highest power? I see x to the 5th is the highest power. So we say the 5th power is known as quintic. 4th would be quartic, okay? So quintic is 5th power. Now there are 1, 2, 3, 4, 5 terms. So we count the terms, which are separated by either addition or subtraction. The constant term is this one, which is negative 1. And once again, we see that the leading term, which is the term with the highest power, doesn't really have a coefficient showing. So in that case, the coefficient is considered to be 1. The leading coefficient is 1. Finally, we see negative x squared divided by 2. So that might be confusing because for the quadratic, recall, we're thinking of it as ax squared, right? So ax squared, where a would be the leading coefficient. What's the a in this case? Well, we should possibly try to rewrite negative x squared over 2 as negative 1/2 times x squared, which is what it is. So in this case, this is the leading term. So it is a quadratic meaning the highest power of x is 2, and there are 2 terms because this term and this term are being subtracted, and the constant term is negative 3. There is no x in that term. The leading term we can write any way we want. We can write it exactly as it is shown with the negative sign. But the leading coefficient, we must write negative 1/2. So to think of it as a coefficient, we would think of it as negative 1/2 times x squared, and that is the leading coefficient.
Alright, y'all, I'm done. So yeah, we're finna be doing it. Real quick, you see this? Oh my God. The what? How to do it? Let me refresh my page. I don't know. I don't know what friend you are, but I'm gonna refresh my page. If I know. Coefficient 8. Constant. 9. X over 5.
Rewrite polynomials in standard form. Rewrite the following polynomial in standard form. So x squared plus 4x cubed minus 1 is 3 terms, but I'm looking over here at the definition of standard form. So standard form for a quadratic, which means if it has x squared as its higher power, is ax squared plus bx plus c. For a cubic, where x cubed is the highest power, we have ax cubed plus bx squared plus cx plus d. And in general, we see that standard form is when we put the term with the highest power of x. For example, in a quartic, the x to the 4th term would go first, x to the 3rd term next, x to the 2nd, then just x to the 1, or x term. And at the end, we put the term that has no x next to it, which is called the constant term. So in this case, we see that there is a cubic, so this is a cubic. Now, the cubic term must go first. That's 4x cubed. Now, the term that should go next is the one with the next highest power of x, which is x squared. And though there is no x term, like for cx, we just leave it, and then we write minus 1, which is our constant. So we should not write plus 0x. We should write the terms that we have that are not 0 in descending order of power. In this case, I see 4 terms, and the highest power is this one, 9x to the 5th. So we should put 9x to the 5th first. Now, the next highest power is 7x to the 4th, but it is negative. So that negative 7 is the coefficient. And when we move it, the negative comes with the x to the 4th. So it's negative 7x to the 4th is next. The 2 remaining terms that we have to write are negative x and positive 3. So we write negative x next, and then positive 3 last, because positive 3 is the constant term. In this case, I have 3 terms, and the first term is x squared over 5, because it's the highest power, then negative x, then positive 5. Now, you might see that x squared over 5 doesn't exactly look like ax squared, so we could think of it as 1x squared over 5, and we could even put the x squared in front here to make it look more similar to the standard form where a is 1/5. So it's 1/5 times x squared. Now, you would have got it right still if you put the x squared over 5 as the first term, but sometimes it's nice to be able to see what the actual coefficient of x squared and write that in front. Finally, we have 4 terms, and the highest one I see is x to the 5th, which should come first. The next one is x to the 4th, which is here. Next, we have negative 5x. Make sure that negative comes along with the x. And then positive 2. Here, we don't have the plus sign in front of the 2 because it is in front, and we don't put a positive. It's the first term. But if we move that to the end, we must put the plus 2 there to separate it from the 5x.
All right. What we're doing. It's been 2 hours with us, yeah. So we damn have to do 5 questions of these. Over 5. Over 3. Alright, now we finna do the buzz on the department, so yeah. How many questions is there? I'm not doing the puzzles, so yeah.
France, to get brought into the conflict. Germany formally declares war on Russia on August 1st, 1914. Germany formally declares war on France on August 3rd, 1914. Germany violates Belgium's neutrality by invading it from August 4th, 1914. October 31st, 1914. Along with the sudden invasion of Belgium and fears of German expansion, Britain declares war on Germany on August 4, 1914.
Ini tadi. Aku dipilih ni kau nak balai dulu. Ini kau tak jaga tu walai. Jadi kau kena. Ayah sini kan di sini.
Intro to Trench Warfare. Trench warfare, while centuries old, was never a widely recognized tactic. That changed early on in World War I while the Germans were invading Belgium en route to France. The neutral country of Belgium only had 200,000 soldiers, who were ill-prepared and equipped. Furthermore, Belgium was in the process of reorganizing its military, further rendering the country incapable of defending against a surprise invasion. Due to these factors, the Belgian king, Albert I, decided that the battle would be that of a defensive. He decided the cities of Liège, Namur, and Antwerp would be fortified and defended with about 80,000 men total.
Damn.
This is where trench warfare was first introduced during the Great War, in which Belgian soldiers would dig trenches and foxholes fortified with barbed wire and other obstacles as a means of protection. Trenches were often built up from the ground using sandbags, due to the high water levels in the ground. Trench warfare eventually became mainstream on the western front of the war, with the combined length from both Entente and Allied trenches spanning 35,000 miles total. German soldiers on the western front dug in the...
later, but come on. Tired, man. I just did it 2 hours. 2 hours doing it. Homework, so now, yeah, I'm taking a break. Yeah, bye, y'all.